Hello everyone, welcome to new class. Today's class is the continuation of eigenvalues and eigenvectors. So in the previous class we have discussed about the eigenvalues, eigenvectors, then characteristic equation, then properties of eigenvalues, etc. So please go through the previous class. Now let us do the problems related to eigenvalues and eigenvectors. So find the characteristic equation, eigenvalues and eigenvectors of the matrix A equal to 1, 2, 2, 0, 2, 1, minus 1, 2, 2. So first of all we have to find the characteristic equation, and that is equal to determinant of A minus lambda I equal to 0. So here lambda I means lambda is unknown scalar, so we have to multiply with the identity matrix, and here this is 3 by 3 matrix, so here we have to take the identity matrix of order 3, that is A is 1 2 2 0 2 1 minus 1 2 2, then minus lambda into I, that is lambda 0 0 0 lambda 0 0 0 lambda. So here we have to multiply with the identity matrix by lambda. So this is A minus lambda I, and which is equal to 1 minus lambda 2 0 0 2 minus lambda 1 minus 1 2 2 minus lambda. So this is A minus lambda I. Now here we have to find the determinant of this one. So that is determinant of 1 minus lambda 2 0 0 2 minus lambda 1 minus 1 2 2 minus lambda equal to 0. Now we have to find the determinant and we get the characteristic equation. So we can directly write this A minus lambda I from this matrix A, that is we have to change only the diagonal elements here, that is just find the difference of this diagonal elements and lambda. Now we can find the determinant of this one, that is 1 minus lambda into 2 minus lambda the whole square, then minus 2, then minus 2 into 0 plus 1, then plus 2 into 0 plus 1 into 2 minus lambda equal to 0. Now we can expand this one. So 1 minus lambda into, this is A minus B the whole square form, that is 4 plus lambda square minus 4 lambda, then minus 2, here minus 2, here we get plus 4 minus 2 lambda equal to 0. Now we can expand this one, and here this is 4 minus 2. So 4 minus 2 is plus 2. So 1 into this one, that is 2 plus lambda square minus 4 lambda, then minus lambda into 2, minus 2 lambda minus lambda cube, then plus 4 lambda square, then here minus 2 plus 4, that is plus 2 minus 2 lambda equal to 0. Then here minus lambda cube, lambda square, 4 lambda square, that is plus 5 lambda square minus 4 lambda minus 2 lambda minus 2 lambda, that is minus 8 lambda, then 2 plus 2, that is plus 4 equal to 0. And let us multiply with the negative one here. So here we will get lambda cube minus 5 lambda square plus 8 lambda minus 4 equal to 0. So this is the characteristic equation. So this is the characteristic equation. Now we can find the roots of this characteristic equation, which is the eigenvalues. So characteristic equation is lambda cube minus 5 lambda square plus 8 lambda minus 4 equal to 0. So here we can use the calculator to find the roots of this equation, or without using the calculator we can find the roots. That is, just put the values from 1 onwards. That is, first put the value 1, then find whether it satisfies this equation, or next try -1, then 2, -2, like that. So let us first put the value 1 here. So it will be 1 minus 5 plus 8 minus 4. So check whether this satisfies this equation. So 1 minus 5 is minus 4 minus 4, that is minus 8 plus 8, which is equal to 0. So this satisfies. So when lambda is equal to 1, this equation is satisfied. So lambda equal to 1 is a root, or else we can write lambda minus 1 is a factor. Then how will you find the next factors? So this is degree 3. So there will be 3 roots and one root is 1. Now we can find the 2 roots. So how will you find the remaining 2 roots? So we can divide this one, that is lambda cube minus 5 lambda square plus 8 lambda minus 4 divided by this factor lambda minus 1. First of all, this is lambda cube. So here we have to multiply with the lambda square to make this one lambda cube. So lambda square into this factor, that is lambda cube minus lambda square, then subtract. So here we will get minus 4 lambda square, then take the next factor 8 lambda. Then next is this minus 4 lambda square divided by the first one lambda. So here we will get minus 4 lambda, that is minus 4 lambda into this one. So minus 4 lambda into lambda minus 4 lambda square, then minus 4 into 1 plus 4 lambda, then again subtract. So here we will get 4 lambda, then write the next one minus 4 here. Now 4 lambda divided by this lambda, that is 4 plus 4 here. So 4 into this one 4 lambda, then minus 4. So this is 0. So next factor is this one, that is here lambda minus 1 into lambda square minus 4 lambda plus 4 is the factor. So by using the calculator we can easily find the factors, or else we can use this method, and which is equal to 0. Now from this one we have to find the factors. So lambda square minus 4 lambda plus 4, this is in the form lambda minus 2 the whole square. So here we can write lambda minus 1 into lambda minus 2 the whole square equal to 0. So here we will get the roots as lambda equal to 1 from here, and this is 2 roots. So lambda equal to 2 here, lambda equal to again 2 here. So the roots are 1, 2, 2, which is the eigen values. So eigen values are lambda equal to 1, 2, 2, that is lambda 1, lambda 2 and lambda 3. So lambda 1 is equal to 1, lambda 2 is equal to 2 and lambda 3 is also equal to 2. So this is eigen values. Now we have to find the eigen vectors corresponding to these eigen values. Now let us consider the relation A minus lambda I into x equal to 0. Now we have to find the eigenvectors. So eigenvector corresponding to lambda equal to 1. So here we will get So what is A minus lambda I? So A minus lambda I is equal to, so this is A minus lambda I. So put the value lambda equal to 1 here. So here we will get 1 minus 1, 0, 2, 2, 0, 2 minus 1, 1, 1, minus 1, 2, 2 minus 1, 1 into x. So x is x1, x2, x3. So this is 3 by 3 matrix. So x is x1, x2, x3 equal to 0. Now here we have to find the rank of this matrix to solve this equation. So for that, let us interchange these two rows. So R1 interchanged with R3. So here we will get 1 minus 1 2 1, then 0 1 1, this one here 0 2 2 into x1 x2 x3 equal to 0. Now these two elements are 0. Now let us make this one 0. That is R3 implies R3 minus 2 times R2. So minus 1, 2, 1, 0, 1, 1, and here 0, 2 minus 2, 0, here also 0 into x1, x2, x3 equal to 0. So what is the rank of this matrix? So rank of this one is 2 because one row is 0. Then the non-zero rows are 2. So rank of this one is 2. So here rank is equal to, or we can write rank equal to 2. Then what is the number of unknowns? Number of unknowns equal to 3, x1, x2, x3. So here R is less than n. So here we have to assume value for n minus r variables. That is n minus r equal to 3 minus 2. That is one variable we have to assume value. Now from this equation we can write minus x1 plus 2x2 plus x3 equal to 0, and here x2 plus x3 equal to 0. Now let us assume x3 equal to k. Then x2 will be equal to minus k. Then from the first equation minus x1 equal to or plus x1 equal to, we can write x2 plus x3, that is 2x2 is minus 2k plus k, that is minus k. So x1 is minus k, x2 is minus k, and x3 is k. So when lambda is equal to 1, the eigenvectors are x1 minus k, x2 minus k, and x3 k. If k is equal to 1, then we can write minus 1 minus 1 1. So this is the eigenvector for lambda equal to 1. So eigenvector corresponding to lambda equal to 1 is x equal to minus 1 minus 1 1. Or you can put the value for k equal to negative 1 also, then it will be 1 1 negative 1. Now let us find the eigenvector for lambda equal to 2. So when lambda is equal to 2, this equation becomes 1 minus 2, that is minus 1, 2, 2, 0, 2 minus 2, 0, 1, minus 1, 2, 0 into x, that is x1, x2, x3 equal to 0. And here there are two elements 0 in this row. So we can interchange these two rows, that is R2 interchanged with R3. Then minus 1, 2, 2, minus 1, 2, 0, 0, 0, 1 into x1, x2, x3 equal to 0. Now here we can make this element 0. That is R2 implies R2 minus R1. That is minus 1, 2, 2, 0, 2 minus 2, 0, 0 minus 2, minus 2, 0, 0, 1 into x1, x2, x3 equal to 0. Now this element we can make 0. That is R3 implies 2R3 plus R2. So minus 1, 2, 2, 0, 0, minus 2, then here 0, 0, 0 into x1, x2, x3 equal to 0. So here what is the rank of this matrix? So it is 2. So here rank is equal to 2 and the number of unknowns are 3. So we have to assume values for n minus r variables. That is one variable we have to assume. So from this equation we can write minus x1 plus 2x2 plus 2x3 equal to 0. Then minus 2x3 equal to 0. So from this one we can write x3 equal to 0. Then let us assume x2 equal to k. Then from the first equation we can write x1 is equal to 2x2 plus 2x3. So x1 is equal to 2k. So what is the eigenvector? So eigenvector x is equal to x1 is 2k, x2 is k and x3 is 0. If we put this k is equal to 1, then we can write it 2, 1, 0. So x, that is the eigenvector x is equal to 2, 1, 0 for lambda equal to 2. And the next eigenvalue, that is lambda 3 is also equal to 2. So eigenvector corresponding to the two eigenvalues equal to 2, 1, 0. So eigenvectors are lambda equal to 1, x is equal to minus 1, minus 1, 1, x is equal to 2, 1, 0 for lambda equal to 2 in two cases. So here x1 is equal to this one, x2 is equal to and x3 is equal to 2, 1, 0. So here x2, the eigenvectors x2 equal to x3. Let us do another problem. Find the characteristic equation, eigenvalues and eigenvectors of the matrix A equal to 3, 1, 4, 0, 2, 6, 0, 0, 5. The first step is to find the characteristic equation, and which is determinant of A minus lambda I equal to 0, and that is 3 minus lambda 1, 4, 0, 2 minus lambda 6, 0, 0, 5 minus lambda equal to 0. Now we have to find the determinant. 3 minus lambda into 2 minus lambda into 5 minus lambda. Then minus 0, minus 1 into 0, then 4 into 0. So here we can find the determinant either along this row or along the first column. So we will get the one element. So which is equal to 0 here. Now we can write this as lambda minus 3 into lambda minus 2 into lambda minus 5 equal to 0. That is lambda is equal to 2, 3, 5. So the eigenvalues are 2, 3, 5. So eigenvalues are 2, 3, 5. Now let us find the eigenvectors corresponding to these eigenvalues. So for that we have to consider the equation A minus lambda I into x equal to 0. So for lambda equal to 2, we have to write this A minus lambda I. So 3 minus 2 is 1, 1, 4, then 0, 0, 6, 0, 0, 5 minus 2 is 3 into x, that is x1, x2, x3 equal to 0. Now these elements are 0. This element we can make 0, that is R3 implies 2 times R3 minus R2. So we will get 1, 1, 4, 0, 0, 6, 0, 0, 0 into x1, x2, x3 equal to 0. So here rank of this matrix is 2 because 2 non-zero rows. So here rank equal to 2 and the number of unknowns are 3. So we have to assume values for n minus r variables, that is 3 minus 2 is 1. So one variable we have to assume. Now from this equation we can write x1 plus x2 plus 4x3 equal to 0 and 6x3 equal to 0. Here we will get x3 equal to 0. Then let us assume x2 equal to k. Then we will get x1 equal to minus x2 minus 4x3, that is minus k. So the eigenvector x1 is equal to x1 is minus k, x2 is k, x3 0. So if k is equal to 1, then we can write minus 1, 1, 0. So the eigenvector corresponding to lambda equal to 2 is x1 equal to minus 1, 1, 0. So eigenvector x1 is equal to this one. Now we can find the eigenvector corresponding to lambda equal to 3. So when lambda is equal to 3, we will get this as 3 minus 3 is 0, then 1, 4, 0, 2 minus 3 is minus 1, 6, 0, 0, then 5 minus 3, that is 2 into x1, x2, x3 equal to 0. Now here let us make this element 0, that is R2 implies R2 plus R1. So 0, 1, 4, 0, 0, 6 plus 4 is 10, 0, 0, 2 into x1, x2, x3 equal to 0. Now we can make this element 0, that is R3 implies 5 times R3 minus R2. So 0, 1, 4, 0, 0, 10, 0, 0, 0 into x1, x2, x3 equal to 0. Now what is the rank of this matrix? So rank of this matrix is 2. So rank equal to 2 and the number of unknowns are 3. So we have to assume n minus r variables. So we have to assume value for n minus r variables, that is one variable. So from this equation we can write x2 then plus 4x3 equal to 0, then 10x3 equal to 0. So from this equation we get x3 equal to 0 and when x3 is equal to 0, from this equation we will get x2 is equal to minus 4x3, that is 0. And let us assume one variable. So we have to assume value for one variable. So let x1 is equal to k. So here we will get the eigenvectors as k 0 0, that is if k is equal to 1 we can write 1 0 0. So this is the eigenvector corresponding to the value lambda equal to 3. So x2 is equal to 1 0 0. Now we have to find the eigenvector corresponding to lambda equal to 5. When lambda equal to 5, This one will be 3 minus 5, that is minus 2, 1, 4, 0. 2 minus 5 is minus 3, then 6, 0, 0. 5 minus 5 is 0 into x1, x2, x3 equal to 0. So, here we got the rank of this matrix directly. So, what is the rank? So, rank of this matrix is equal to 2 because 2 non-zero rows. The number of unknowns are 3. So, we have to assume value for n minus r variables, that is 1 variable. So, from this equation we can write minus 2x1 plus x2 plus 4x3 equal to 0 and minus 3x2 plus 6x3 equal to 0. So, let us assume value for x3. So, let x3 equal to k, then minus 3x2, or we can write plus 3x2 is equal to 6x3. Then what will be x2? So, x2 is equal to 2x3, that is 2k. Then from the first equation we can write 2x1 equal to x2 plus 4x3, that is x2 is 2k. So, 2k plus 4k, that is equal to 6k. So, what is the eigenvector? And this is 2x1. So, x1 is equal to 3k. So, x3, that is the eigenvector x3 is equal to 3k, then 2k, then k. And if k is equal to 1, we can write 3, 2, 1. So, this is the eigenvector corresponding to the value lambda equal to 5. So, x3 equal to 3, 2, 1, 4, lambda equal to 5. So, these are the eigenvalues and eigenvectors corresponding to these eigenvalues. So, in this way, we are doing the problems related to eigenvalues and eigenvectors. So, thank you for watching the class. If you like the classes, please like, share and subscribe my channel.